Hi there, how's it going? Today I'll be walking you through on how to integrate SCANOSS with Dependency Track for continuous vulnerability monitoring and policy enforcement. So getting right into it, what we need in terms of prerequisites are a running instance of Dependency Track, a GitHub repository. So as this integration is done through GitHub, I'd require a GitHub repository, a Dependency Track API key, and the steps to getting one are visible on the screen. And you would also require the scanoss API key. So I've created my own GitHub repository and I've loaded it up with a number of JavaScript files which I'd like to scan using scanoss and then display these components in Dependency Track. Once we have that, now we need to store secrets in GitHub so our workflow can access them without hard coding any credentials. What we have to do is actually navigate to the repository, go into settings, scroll down, secrets and variables, actions, scroll down and you'll see the repository secrets here. Now I actually have mine configured already, but as you see I have three. DT API key, so it's the Dependency Track API key. So you click new repository secret, mention that name, and then put in your secret here and then click add secret. Do the same thing for the others, so Dependency Track server URL and scanoss API key. I'll then go back to my browsers and search up scanoss GHA. Click into scanoss code scan action. It'll bring you to the repository of the scanoss GitHub action to scan your source code using the scanoss platform. What you'll do here is scroll down to the very bottom where it says the full example, copy this, go back into your IDE. Okay, so now that we've copied the whole workflow file, all we need to do is actually open the IDE and open the project itself. Then inside the project here, we're going to create a folder called .github and then create another folder in here called workflows. Now inside of workflows, what you want to do is create a file called scanoss.yml and then paste that whole workflow here, which is the core of the integration. Make sure you're using the latest scanoss version. The latest I know is 1.6.1 and save that as well. So to quickly walk you through the workflow here, on every push and pull request to any branch, this workflow gets executed and your code will get scanned. These permissions right here allows the action to actually read your code, write any results and post comments without needing any extra access. Moving down to the job section here, we can see that we're using the code scan action version 1.6.1. So the policies we've enabled are copyleft, undeclared, and dependency track. The scan mode is set to delta. However, I'm going to change it to full to enable a full scan of my entire project. Dependency track dot enabled is set to true. Dependency track upload set to true. Dependency track URL. Now for this one, you'd actually need to switch it to a secrets value as we store the relevant secret in GitHub. So we'll need to change it to DT server underscore URL. We also need to mention the project name, project version, the scanoss API URL. We don't need to mention this. However, we do need to mention the API key, and that's also a secret value. So I'll have to set it to secret.scanoss API key. I'll change it here. Save that. And at the bottom here, we have two print steps that just lets you see the raw scan command and results directly in the action log. And this is useful for debugging. Now, as I mentioned, the project name and project version, you're free to change these to whatever you like. For me, I'm setting them to my project and 1.0.1. So what we do now is push these changes to GitHub. First, I'd add all these changes by doing git add and committing this with a comment. So git commit -m, scanoss dt integration. As I'm not on the main branch, I'm going to do a git rebase main, and then I'm going to run the git push command. Perfect. Now that we pushed our code, if we go back to our GitHub repository, click on pull requests, go into new pull request, and click on the second branch. So set the compare branch to the branch that I created and the base branch to main. Click on create pull request, give that a second, create pull request again. As you can see here, the workflow will start then executing a number of policy checks, so copyleft, dependency track, and undeclared, and the full scan as well. So give it a second, let that load. Perfect, so now that the workflow is complete, let's review it. The first comment we see here is code similarity detected. It mentions that there's one snippet match found and two full file matches found, and we can view the details by clicking on the detailed findings here in the commit. We can see there's 3 comments here and it says full file match found in the following file. Down we can see a summary of what has been scanned, and then clicking on this link, we can see, it says here view more details on the following action summary page. So let's click this link. So first thing that comes up here in the summary is the scan report section. So we can see the licenses here. It mentions MIT and CC0 1.0. Going further, we can see the policy checks. Moving down to undeclared, we can click on more details here. It'll bring up the policy check, the undeclared policy check section. So it mentions here there's the following components have been identified under the following licenses and they're undeclared, meaning that a scanoss.json file is not present within our project. So these files, these components are not declared within the project itself. And one way to fix this policy is to actually declare the components and store a decision. And the way you do that is you create a scanoss.json file. You can do so by clicking this button right here or downloading the undeclared results and creating the file yourself. This is a sample of what the contents should look like declaring the component. Going further, we can see that there's a dependency track policy as well here. Before clicking into that, I'd just like to cover this summary page. So the details, we can see that there's a status check for dependency track to check if the project was successfully uploaded or not. There's a green tick here, so that's a good sign. Mentions the link of the dependency track project as well, mentions the annotations, so explaining where the full file matches were found, where the code snippet matches were found, and you can download the relevant artifacts. So dependency track policy results, dependency track undeclared results, scanoss cyclone.dx file, the raw file, the SBOM in CSV format, and the SBOM in SPDX-Lite format. Focusing on dependency track here, we can check the status check. As you see here, it says upload details, project name, project version, project ID, mentions the actual URL of the dependency track, the SBOM I used to upload and populate the dependency track project, the upload time, and you can actually view the project by clicking the link here. We can click on the policy check here as well in dependency track, and we can see what policy was violated. So as you see, it says here the component, the policy name, security, risk type, security, and state is failed. So we can download the dependency track result, or actually we can go into the dependency track and view the violation ourselves by clicking the link here. Loading up the project in dependency track, we can see the following page. It gives you an overview of the project. It mentions the project vulnerabilities, policy violations, components, and the auditing process as well. As you can see, we have one policy violation, one component, a number of vulnerabilities, and we get the exploit predictions as well. So clicking on the auto vulnerabilities section, we can manage these vulnerabilities by clicking on each of them, analyzing the details, and then setting the analysis value to effectively manage them. You can add additional details such as comments, justification, vendor responses, and details. Moving further to policy violations, we can see the following risk, and this is one that I actually created in the policy management console. So you can actually create your own policy violations by going into policy management, clicking create policy. As you can see, I named mine security critical, set the operator to any violation state to fail. You have 3. Information, warning, and failure. Set the condition to severity, set the value to is, and if it's critical, the policy violation will be highlighted. Same thing with the EPSS score. If it's greater than 0.5, highlight that as a policy violation. So now when I scan a project in my dependency track and these conditions are met, the project will be then highlighted with policy violations, and you will see them in the policy violations tab. You can also create violation policies for different license groups as well. So as you see here, I created a policy, named it test, set the operator to any validation state, set it to inform, but you can set it to warning or failure. Condition, set that to license if the license is, and select any of the following license to get notified when one of these are contained within your project. So once you set up your own policies and start scanning your own projects, you'll essentially get all these policy violations. And what you have to do is actually review them. Some are acceptable, some are not. So clicking into the policy violation, clicking analysis, you can mark the status of the violation. The options you get are not set, approved, and rejected. So if you approve this policy violation, you click approved, and that value is then saved. And that's pretty much your whole integration. From a single push to a GitHub branch, scanoss scans your code, generates an SBOM, uploads it to dependency track, and your entire compliance and vulnerability management workflows runs right there. Thank you so much for watching.